Okay, for today, two things. I need to just do a little bit of review, and that's just a little bit. Um, let's say I asked you on a test that had an average score of 17.5. By the way, grab your calculator. You're going to have to use a calculator on this. Average score is 17.5 and a standard deviation of 1. What percent of kids would have got between 16 and 17.5? Do you know which little tool to use? Don't say it. 16 and 17.5. What percent of kids would be in there? All right, now you can tell me what tool are you using, sir? Normal CDF, very good. As opposed to, what's the other thing we learned? Inverse normal, okay. And let's use that in a moment, but first this answer. There's four numbers. It goes 16, 17.5, and then it needs to know the average, which was 17.5, and then it needs to know the what? Standard deviation, which was 1. And then you hit enter, and it would tell you AE. What did you get? You got this one? Okay. All right. How about you? A little louder. 4, 3, and that's probably good enough. Raise your hand if you had 43%. All right. Why is there such a big number of people in there? It's almost half the people have that score. What's the main thing driving that? Is very close to the mean, and aren't most of the answers in a normal distribution close to the mean? Yeah, and the standard deviation is very low. In other words, most people are really close to the mean. That's why that number is pretty big, 43% chance. All right, now this. Kid says, I think I did pretty well on this test. By the way, if the average is 17.5, if the kid actually did pretty well, like 95th percentile would be pretty good, right? Well, what would a 95th percentile score be? One of your little tools can tell you that. Kid said, I think I did really well. Like maybe even top 5%. That'd be the same as 95th percentile. One of your tools does that. Inverse normal. And you start with saying the percent this time. Instead of them telling you the percent, you tell it the percent. And then what else do you have to tell it? The average, which was 17.5, and the standard deviation, which was 1. And what does it tell you? What score you needed to be in the 95th percentile, which would be what, sir? Ooh, it's 19.1, and I like the way you're saying this, though. 19.1, you could say that that's what you need, but you can't actually get that on a test, can you? All right. If they go by half points, then what's the lowest score you could get? 19.5. All right. And now some of you are like, but it was out of 19. Well, the calculator doesn't know that. The calculator doesn't know how many points were possible. All right. So I know that can get messed up in the real world. The standard deviation being 1 around an average of 17.5 is not normal distribution. Now I was assuming it was normal distribution, but technically it wasn't. And we won't fool you like that on the test. I'm just trying to say why this didn't work out nice, because it wasn't a normally distributed population. Okay, that's enough review. Now let's talk about the new stuff. If I gave you 2 sets of data instead of just 1, like if I didn't just say, here's your shoe sizes, but okay, if I asked for your shoe size and your pinky length, do you think they would correlate? What's your gut feeling on that? If I took everybody's shoe size and pinky length, do you think there would be a correlation? Yeah, because People that have really tiny feet are likely to have, smaller hands. Is it a guaranteed? Of course not. And there's almost nothing that has a perfect correlation. All right, so I'm going to give you a simple one. It's going to be, these are days in May. If we just took random days in May of this month, we have anywhere from, there was a high of like 80, and then there has been a high of like 40. Okay, it can be all over the place. But if we took an average over the last 100 years, average on the 1st of May, compared to the 2nd, compared to the 3rd, compared to the 4th, would you agree generally it's probably heating up? Average over the course of May, it's probably heating up. Okay, this is the high temperature for the day. All right, so I'm going to give you some dates, 1, 2, 3, 4, and 5. And then if we took the average temperature in May, on May 1st, for the last 100 years, and let's say it came out to 51, not saying it would, but let's say it was 51, and let's say this is 52, and 53, and 54, and 55. Do you get that that would be pretty much a perfect correlation? Yeah, probably not even likely to be that perfect. But if it was, then that would have been an R factor, which is a new thing that you don't know yet, an R factor of 1. That means as your data is really, really tight, like if you graphed it, it would make a nice straight line, like doot, 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 doot. As opposed to the real world where a lot of times the data looks much more like that. Yes, it's kind of going up, but it's more lumpy. It's not perfect like that. So therefore, an R value of 1.0 is very rare. That means it's positive and perfect. An R value of -1 would be like that. See how they're all lined up perfectly? Perfect correlation, but it's going down. Are there things that do that? Yes. Like for instance, can you name anything where as one thing goes up, the other thing goes down? Okay. As the date moves up in the summer, your days of summer that you have left go down. Does that one make sense? As this is the first day of summer and there's a lot of summer left. Second day of the summer, there's less summer left. I know it's not that steep, but want to get really depressed, every day you live, you're a day closer to the end of your life. Okay. Anyway, how about this? Is R positive or negative? Is it -1? No. By the way, if perfect positive is +1, and perfect negative correlation is -1, then a lot of times things are in between, right? What's exactly in between? 0, and that means there's no correlation at all. Like the word I say next, and the color of the average panther in India. They're not related. No correlation. Unless it's the butterfly effect, where I say this word, which causes you to sneeze because I said pepper, and just thinking about pepper causes you to sneeze, which then disturbs a kid in the hallway who's afraid of sneezing for some reason. He runs out into the parking lot, which then in turn causes, okay, anyway, there's a kind of a cool movie called Butterfly Effect. So in other words, one little thing, and it kind of like causes this stampede of antelopes, which changes the wind pattern, which then affects the weather and then causes a tornado in Arkansas. All right, anyway. So here's my question. I'm going to change this a little bit. If this is your data, I want you to figure out Well, I know you know that it's got a positive correlation, but is it 1.0? No, it's not. But I want you to figure out what it is. All right. So the old calculators and the new calculators are different on this, on how to set up what's called diagnostics. But all of the calculators will work if I do it this way. Would you please hit the button above 0 on your calculator, which is called the catalog. It is the most powerful button on the calculator because it's the one place where you can get everything. Everything is under catalog. Every possible thing you'd want to know on your calculator, like absolute value is one of the first things you see. You know what I'm talking about? And it's also alphabetized instantly. And so if you want to have your diagnostics with a D turned on, then you need to hit D next. It's in alpha mode automatically, so I'll show you. I go to above 0, and then I got to find D for diagnostic, and D is the green D that's above this key, so it's already in alpha. Don't hit alpha. There. And now diagnostics, I got to arrow down until I see diagnostics. And by the way, there is another way to do this, I know, but on a fair number of kids in my class do not have the newest version of the calculator, and so they have to do it this way. So I'm just having everybody do it this way. Turn diagnostics on and hit enter. Okay, that wasn't super deep, but now when we go to the next thing, the diagnostics will be on and it'll tell you what your R factor is. Okay, everybody hit stat, hit enter for edit, and we're going to edit list 1 and list 2 at the same time. In the past, we've only put in one list at a time. Now, this one's going to be L1, and this one's going to be L2. Put them in. Sliding this over a little bit. 1, 2, oh, mess up already. 2, 3, 4, 5. Deleting that one. You can't have any extra numbers in your list. And if you don't have the same exact number of numbers, it's not going to like it. 51, 52, 52. What? Well, because I didn't want it to be perfect. 54 and 57. All right. Raise your hand if you have got your numbers in the list. Okay, good. If not, you need to catch up quick. Okay. I'm going to stat. Now I'm going to calculate. You might think I'm going to go to two various stats, and I'm not. I'm going to linreg. You know what that stands for? A linear regression. Now, you guys don't hit it yet. If you already have, then just watch mine. See how it says ax plus b? What if that said mx plus b? Would you recognize it then? It's slope-intercept form of an equation. So what they're going to do is give you an equation in slope-intercept form. It's just that in Texas, where they made the Texas Instrument Calculator, they don't use M for slope. They use A. Remember me saying that before with factor, greatest common factor? There is no GCF. There's only a GCD. If I never mentioned that before in here, it's because we didn't do much with that. But no, it's not. GCD is not greatest common denominator. It's greatest common divisor. Because in Texas, they use the word divisor, not factor. So, again, this calculator is not perfect. No big shock. But that's mx plus b form. I'm hitting enter. I'm going to enter in L1, L2. And now this is a part where I can't help you. People that have the old version, you don't have this menu. That sucks. But what you do is type L1, comma L2. Who are my people in here that have the old calculator? It does not have this menu. All right, so there's like 5 of you. You have to type in L1, which is right above the 1 key, comma, which is right above the 7 key, L1, comma, L2, comma, and now everybody needs to type in Y1, whether you got the old version or not. L1's first, L2's second, and then you say Y1 right here. What the heck? Where's Y1? It's buried deep. You ready? Vars. It would have actually worked to go to catalog, but I'm going to go to vars and then go to yvars. And you don't even know what parametric and polar are, so don't touch them until you're in pre-calc and you know what you're doing. Function y1. Now, what do you think that's going to do? It's going to store the regression equation on y1. Do you get? It's going to enter it onto your calculator on the Y1 line. All right, I'm going to hit enter, and boom, here's my equation, and even better, if I go to Y1, there's my equation. Now, if yours didn't do that, I'm going to arrow up and see if I can find that right there. That's what it should look like if you have the old calculator, L1, comma L2, comma Y1. That was under vars, Y vars, etc. Okay, and there it is. And what does it mean? What it means is A right here is 1.4. B is 49. So it's Y equals, okay, you guys that have been talking all hour, you're going to need to knock it off. Y equals 1.4x plus 49. So I've got an equation here where I've got a y-intercept of 49, and it seems to be going up about 1.4 degrees each day. Do you get how that kind of works with this? Every day it seems to be going up a little bit. All right, you know what this can do? This can predict what the temperature would be on the 6th, even if it isn't the 6th of May yet. Even in the real world it is, I know. But you get what I'm saying. It can predict the future based on the past. All right, so this is a powerful thing. It can make correlations, predictions. Do you remember that one that I talked about with your pinky length? They have a chart so that if they can find a bone every now and then, like somebody's dog is out playing in the woods and it comes back with a bone in its mouth, and then the person looks at it more closely and like, oh, that's a human bone. And then they realize, oh my gosh, that's a dead body. And then they have to figure out, well, we can't just, like, we take dead bodies very seriously. Can't just be like, oh, that's interesting, I'm going to put it on my mantle. No, you have to take that, and they're going to figure out who that was. And so they're going to take that bone to a chart where they have done a linear regression just like this. And they can say, oh, from this bone, I can tell that the person was 6'7". And then they're like, was there any people missing who were 6'7"? Yes, there was, and it must be him. And then they can run the DNA tests and all that stuff. So yeah, just from a bone, they can figure out how tall the person was, which really helps narrow it down. Unless they were like 5 foot right in the middle, like let's say 5'10". A lot of people are 5'10". Probably didn't help very much, but okay. All right, enough about that. What was my R value? 0.92. Would you agree that kind of makes sense because it wasn't perfect correlation, but it was pretty strong? All right. There you go. You've learned everything that you're going to need to know for today. Let's just do one more little tweak. We'll change our numbers a little bit to see what a negative correlation is kind of like. Let's say this was December. Do you get that the temperatures would be dropping? So let's leave the 1, 2, 3, 4, 5 alone. And let's make our temperatures for the L2 list change from high temperature of, let's say it's dropping from 50 to 49 to 47 to 46. And I need one more. Let's make it not quite so perfect and make it a 42. Sure. It's the meaning of life anyways in the Hitchhiker's Guide to the Galaxy. All right, would you please put that into your calculator, figure out its R value. I hope it comes out negative because it's going down. And then we'll see how good the correlation is. I wonder if it's better than the other one. Because it's point what? 0.96. That's a very strong correlation. A strong negative correlation. And then if you really understand this, you should be able to tell me what December 7th, a date that'll live in infamy. If we go to December 7, you should be able to tell me what temperature it should be. Because you should be able to have an equation that you stick numbers into and you can solve. Can you tell me, please, sir, on your calculator, what was the little regression equation. Y equals point what? 5? Thank you. All right, then where did you put the 7? Yep. Do you get then that you can figure out the answers the other way too? What if instead I said, I want to know when the temperature is going to drop all the way to 38. Then the 38 doesn't go here. The 38 would go here. Now you'd have to use just plain old-fashioned algebra and a piece of paper to solve that one. There's a way to do it on the calculator, but it's more complicated than just saying, you can solve that. Subtract 52.5 and divide by negative 1.9, and you'd have it. Okay, there you go. I think that's all you need. You're going to be doing problems 1, 2, and 3 on the worksheet, skipping problems 4 and 5. Are problems 4 and 5 bad? Nope. I'm just trying to keep the assignment reasonably sized. And so far, your test scores have been coming in just fine compared to all other people's test scores, which implies maybe you don't have to have all that homework. But I actually think I might have a higher percentage of kids doing the homework because I'm keeping it smaller. So I'd rather have everybody doing it than only having a few super dedicated kids doing it and a lot of people saying, that's too much, I can't get it all done. And I think that might be part of the secret too, is a lot of people are, not everybody, but a lot of people are doing their homework. All right, that's all I have for you for today.